currently?
Yes, sir.
Currently, which exams are left? Which papers are left?
Hindi, English, and social science.
You have Hindi also.
Yes, sir.
Okay, okay. Hindi, English, and social science. Okay, okay. So you have covered all those subjects.
Yes, sir.
Okay. And once the exams are over, do send the pending assignments. All right, Mafas. Okay. Now, the chapter we are going to begin today is the combustion, and flame. Okay. So you see, what is combustion basically? Any substance which burns in the presence of air, okay, and which gives off heat and light. Okay, that is simply called as combustion. Okay. So in simple words, combustion basically means burning. Right. Okay, just give me a minute. I
Okay,
have
sir.
urgent call coming. Just give me a minute.
Oh, okay, sir.
Yes, Mafas. Yes, Ahmed. So we were talking about
Yes, sir.
combustion, right? So whenever a substance
Yes, sir.
burns in the presence of air, it will give off heat and light, right? So heat and light is produced whenever a substance is burned. And in simple terms, we call it combustion, or simply burning of any substance will be termed as combustion. Okay, so this is what we are going to be covering in this chapter. How the chemical process of combustion takes place and what are the different types of flames produced during this process. Right. So there are some substances which gives off flame when you burn it, and there are some substances which will not give a flame when you burn it. Right. So we begin the chapter and combustion here. Read the two paragraph here. What does it says?
A chemical process in which a heat substance reacts with the oxygen to give off heat and light is called combustion. The burning of wood is an example of combustion.
Exactly. Okay. Burning of wood is an example of combustion. Other examples is burning of magnesium. So burning of magnesium, that is also an example of a combustion. So ever seen iron workers, fire workers? They basically blend two metals. They join two metals with magnesium ribbon by burning the magnesium ribbon. Okay. Have you seen the fire workers or the iron workers? Basically, people. Yes,
Fireworks, sir.
ironworks. Ironworks.
No, sir.
Ironworks where iron and steel. Okay, you see, people. It's basically a small scale industry where manufacture of iron objects and steel objects takes place, where two different iron objects are blended together or joined together. So when you must have seen it back in India, like there are small shops where people operate at a small level where iron objects are
Yes.
joined together by using a magnesium ribbon.
Okay, sir.
Okay, that gives off a very sparkling light. Okay, so in all the combustion process, basically what happens, the substance will basically uh, it will burn basically in the presence of oxygen, and it will give off heat and light. Take example of this magnesium here. So magnesium in presence of oxygen, it will burn. Okay, and it will give you heat plus light, and magnesium will combine with oxygen to give you magnesium oxide. Magnesium oxide. Okay,
Okay,
so
sir.
this is the burning of magnesium. Okay, and what is happening here? That is combustion. Okay, so what happens? What are the elements required for combustion? We will need some fuel, we will need oxygen and heat. Okay, we will be needing some amount of fuel for combustion to take place. Either wood will be burning, either coal, either petrol, either diesel, either it will be biogas, right? So that will serve as the serve the purpose of fuel. Then those fuel will burn in presence of oxygen, right? And some amount of heat has to be given to those fuel to burn. So that will exhaust and give you heat and light as well. Okay, so that's all about
Okay, sir.
combustion, right? So apart from magnesium, you have got combustion of charcoal as well. Okay, so charcoal, it is mainly made up of carbon. Okay, so if you hold a piece of charcoal with a pair of tongs, you know what is tong? It is basically a simple tool used to hold objects. Okay, in a chemistry lab, you might
No,
have
sir.
seen it. Look, a tong looks like something, it looks something like this. Okay, in between the two, these two, some objects are held like this. Say this is a piece of charcoal. So using a tong, you can hold it like this. This is called a tong. Okay.
Oh, yes, sir. I have.
Yeah. Okay. So when you heat it on a flame of a burner, it will start to burn. Okay. So basically, it goes under combustion, right? And we know that
Yes,
charcoal
sir.
it consists of carbon. Okay. So when you burn charcoal, or we say that it is mainly made up of carbon. So charcoal plus oxygen, then when it undergoes combustion, it is going to give off heat plus light, as well as it will
Yes.
give you carbon dioxide as well, CO2. Right, Amit? Okay, so these are some examples of combustion here. Okay, now let's talk about what are the combustible and non-combustible substances. Okay, like take a piece of paper and try to light it with a matchstick. So it will easily catch fire, right?
Yes, sir. Yes, sir.
Okay, so there are substances that catches fire easily and are combustible substances. Okay, and let's take another type of substance. Let's say that you take a piece of rock. Will you be able to burn it using a matchstick?
Yes, sir.
If you
Can you
take
repeat?
if you take a piece of rock, okay, and you try to burn it
Yes.
using a matchstick or using any form of heat, will you be able to burn it?
No, sir.
No. So we conclude from this that in our surrounding there are some substances that burns and there are some substances that does not burn. Right, Ahmed?
Okay, sir. Yes, sir.
Okay. Now I was actually expecting you to ask me this question that, so how does heat gets produced in sun? Is sun also burning? But we know that for burning, oxygen is required. In space, there is no oxygen, there is only vacuum. So how does sun burn? How combustion takes place in sun? Does Ahmed?
Oh, yes, that's a
How
good question, but
sun burns? Look, what happens in the sun? There are some nuclear reactions going on in the sun. Okay. Nuclear reaction takes place in sun. Nuclear reaction takes place in the sun. Okay, and for nuclear reaction, sun does not require oxygen. So what happens in this nuclear reaction? Hydrogen gets broken into helium. The hydrogen gets broken into helium. Okay, so that leads to emission of excessive amount of heat and light. So that releases light plus heat. So this is how sun gives off enormous amount of light and heat. Okay, so we were talking about combustible and non-combustible substances. So in our nature, not all substances catches fire. So not all substances are combustible in nature. So some substances are combustible and some substances are non-combustible. Okay, so what are some examples of substances that catches fire easily? What are examples of combustible substances?
paper, wood, and
Yeah, wood.
plastic.
Yes,
Plastic.
plastic. Okay. In fact, you can include all the different types of fuels we are studied in the previous chapter.
Is the fuels also
Petrol, diesel,
kerosene and LPG.
bitumen.
Yes, bitumen, LPG, and CNG.
Exactly. CNG. Right. We can include charcoal as well in this.
Yes,
Charcoal.
Also coal.
Coal also. Right. You can in fact include cow dung cakes.
Yes, sir, and clothes. Say clothes.
Yeah, clothes
Cotton.
as well, but usually we don't use them as combustible substances. Then you have got alcohol as well. Alcohol also catches fire easily.
Yes, sir.
Right. Alcohol, matchstick. Okay. In fact, magnesium ribbon also. Okay. These are all examples of magnesium ribbon. RIBBON.
Okay.
In short, you can write magnesium as Mg. Okay, so combustible substances. Okay. Likewise, we have got non-combustible substances also. What are some examples?
No, like rocks and bricks. That would be in rocks category.
Rocks, bricks.
And solid substances usually, sir, don't catch fire.
Soil. Right. Solid substances usually do not catch fire. No, we have got examples of magnesium ribbon, matchsticks, coal and charcoal. Those are solid substances.
Yes.
Okay, so we have got rocks, bricks, soil, water, etc. These are non-combustible substances.
So is electricity non-combustible?
Electricity in itself is not a product. It's not a fuel here. It's not a substance. Electricity, it basically consists of charges. Okay, so electricity may be reason for objects to cause fire, to catch fire. Okay, but in itself, electricity is not a component. Right, Ahmed?
Oh.
Okay.
Yes,
Now, see, we have got two interesting activities to perform here. Okay. Okay, read activity 4.1 here. What does it say?
Activity 4.1, collect some materials like straw, matchstick, kerosene, oil, paper, iron nails, stone pieces, glasses, etc. under the supervision of your teacher. Try to burn each of these material one by one. If combustion takes place, mark the material combustible, otherwise mark the non-combustible.
Okay, let's quickly
And
do
there's
this
a
activity.
wood is a combustible, so check it mark.
Yes,
Paper is also combustible, and iron nail is in, and kerosene oil
it
is
is.
combustible.
Yeah,
Yes, and non-combustible stone piece.
yes,
Straw combustible.
that is combustible.
Yes, and charcoal is also combustible.
Yes, very good.
Matchsticks are also combustible, and glasses aren't non-combustible.
They are
Glasses are
non-combustible.
non-combustible.
Yes.
Yes, sir.
Okay. Now see activity 4.2 here. Okay. Are the text
Fix
visible? Can
a,
you read it with ease?
yes, sir. Fix a lighted candle on a table. Put a glass chimney over the candle and rest it on a few wooden bricks in a such way that air can enter the
Chimney.
chimney. Observe what happens to the flame. Now remove the block and let the chimney rest on the table. Again, observe the flame. Finally, put a glass plate. Uh, what? Wait, no. There was a glass plate over the chimney. Watch the flame. What happens in the three cases? Does the flame flicker oil? Does it flicker and give smoke? Does it burn unaffected? Can we learn anything at all about role played by air in the process of burning?
Yes, Ahmed. So what do we conclude from this activity? What do you observe here? See, there a candle is being burnt here, and there are three different setups. Okay. In the first one, okay. Now is the container open from both the sides? Yes, it is hollow
So,
container. Okay.
okay,
In the first figure, you see wooden blocks have been placed at the bottom of the container, and the container is resting on these two wooden blocks. So this candle has access to air from both the sides, from the top of the container and from below of the container also air can pass through the container here. Okay. So we see that the candle is glowing here, right? Now
yes, sir.
see in the next figure, in figure number B, what we have done here, we have removed the wooden blocks from here. Okay. And we have let this chimney to rest on the table. Okay. So after some time, this will get extinguished. Okay. It will
Yes, sir.
after some time, or if you closely see the figure, smoke has accumulated in this figure, in the container, right, Ahmed? And see the
Yes,
third
sir.
figure here. We have stopped the inlet of air from both the sides. Now we have placed a cardboard on top of the chimney. So neither from bottom, neither from the top of the container, air can enter this. Hence, the
Okay,
candle will turn off. Okay, the candle will flicker off. Okay,
okay, sir.
so what do we conclude from this activity here?
We conclude.
Look, it has got to do something with air, no? Like we
Yes.
are basically cutting off the access of air to this candle.
So it gives.
So we basically conclude from this activity that air is necessary for combustion, right, Ahmed?
Okay,
So
sir.
we are talking about conditions necessary for combustion. Okay. The first thing we got to know from this activity is that air is required for any substance to burn. Okay. So presence of air, that's the first requirement. Okay. Now next requirement for any for combustion to take place is that there has to be a combustible substance.
Yes,
Okay.
sir.
We need to have a combustible substance for combustion to take place. If we have a piece of stone or a piece of glass, there will be no combustion. Okay, you keep on providing heat and air to it, the substance is not going to catch fire. Okay. Although that's another case that if you throw it in a volcano, then it will catch fire. But here it is not going to catch fire under normal circumstances. Right, Ahmed? So presence. And have you been taking notes of the class or not in your copy?
Sir, I haven't took the note of this chapter, sir. I haven't taken any notes of this chapter.
The previous chapter, no? Coal and
The,
petrol.
okay, sir, I have taken some notes.
Okay, okay. Okay, so I will do one thing. I will share the PDF of the previous chapter to you guys. Okay. And only because you haven't taken notes of the class. Okay, that is the reason I will be sharing the PDF. Okay. Otherwise, you guys are required to note down the important things discussed in the class. Okay, and you have to note those things in sequence wise. Okay, like where did I started the chapter from? I first talked about combustion. Okay, then you will write the definition. Then I gave you some examples of magnesium, of charcoal. Okay, so I'm just explaining to you how you need to take notes in a sequence. Then you will write down about combustion and non-combustible substances and give some examples as well. Then you will write down the conditions necessary for combustion. So this is how you need to take notes of the class. Okay, so that it will be convenient for you to revise things when exams are near. Okay, Ahmed.
Okay.
Okay. Now, another most important thing is that, look, if I give you a piece of wood here, okay, if I give you a piece of wood here and I ask you to burn it using a matchstick, will you be able to burn it using a matchstick?
Yes, sir. Can you repeat? I couldn't hear you.
This is a piece of wood, okay, and I ask you to burn it using a
Yes.
matchstick. Now, will you be able to burn the wood using a matchstick? Will you succeed in this?
No, sir. If only I'm going to use one matchstick, it won't work, sir. We need a bigger fire.
Exactly. Because the thing is that any substance, any combustible substance requires a minimum required temperature to burn. Okay. Like the wood might require 80 to 90 degrees Celsius to burn. Just giving an example. Okay, that exact value could be different depending upon the different types of wood. Or let's say you have a piece of coal here. Okay, so you might also not be able to burn a piece of coal using a matchsticks. Okay, because different combustible substances requires different minimum amount of heat to burn. Are you getting this? What I'm saying?
Yes, sir. Yes, sir, I am.
Basically, different substances starts to burn at different temperature. So that we are going to talk about later on when we will have discuss some more things. So that thing is basically called as ignition temperature.
Okay, sir.
Ignition temperature, right? So these are not basically main conditions required for combustion to take place. What are they?
Yes, sir. Can you again repeat?
Yes. Am I not audible to you properly?
No, sir. Wi-Fi isn't just nice.
Okay. Ignition temperature. I told you that what are the conditions necessary for combustion? They are mainly three. What are they?
The fire, heat, and hmm, I may have forgot the last step, sir.
Yeah, I'm writing it.
Oh,
Heating
and
the
present. Yes.
substance to its ignition temperature. To its ignition temperature. All right. So three things are required for any substance to catch fire. Like in the beginning, I told you, it requires a fuel Fuel is what? A combustible substance.
Yes, sir.
Okay. And it will require oxygen, that is air, and it will require heat. So heat, different substances will require different amount of heat to burn, right? So that heat we have gave it a term called ignition temperature. Okay, like to ignite, ignition comes from the word ignite. Ignite means to catch fire. So different substances will catch fire at different temperatures. So we call it ignition temperature. Okay, now
Okay, sir.
see here. What would you do if you see a person who has caught fire?
Yes, wearing a scarf.
If a person catches fire, no, this person is not wearing a scarf here. Okay, this person caught fire.
He
Okay,
then
so we
if
will cover the person using a thick blanket.
yes, sir.
Okay,
But
now you,
why?
but why would we do this? Can you explain it to me?
Uh, sir, because the blanket isn't a very good conductor of heat.
Blanket is not a good conductor of heat. No, that is not the thing here. Look, for heat, what are the important things required? For combustion, what are the important things required? For anything to burn, what are the important things you need? Like the person has caught fire here. Okay, basically, we are talking about combustion here.
Yes, sir.
Okay, and we need to stop the fire here. Okay, so we basically wrap the person with a thick blanket here. So how does it help to stop the fire? First thing, it
Blank-
cuts. Yes.
the heat can't pass through a thick blanket or
No,
the
it is
fire.
no, that is not the main reason, Ahmed. The main reason is no. If you see the answer is hidden here. The conditions required for combustion. The answer
Oh,
is written here. Can you find it from here? Okay, I will give you a minute. The answer is hidden in first three, in these three conditions. Look
uh,
here. Yes.
find the that for combustion. We find that for combustion, air is necessary. The candles burn freely in the case. When air can enter the chimney from below in case H. When air does not enter the
Look, Ahmed. What happens now? When you are wrapping up a piece of blanket around that person who has caught fire, the air supply is cut off. Air supply, it is cut off. Okay. So now, due to air supply being cut off, the fire will stop. That is the reason why a person is wrapped with a blanket or a thick blanket, because the access to air is cut off. Got this now? Okay, Ahmed. If you got this now, let's move ahead then. Okay. Now let's talk of type of combustion. Like combustion is also of two different types.
huh?
Combustion is also of two different types here.
Non-combustion, sir.
Yes.
Non-combustion and combustion.
No. That is the types of substances. Okay, like we have got combustible substances and non-combustible substances. The process, we are talking about the process of combustion here. Okay. Or the types of combustion in this, we are basically going to talk about those substances which will not immediately catch fire. Okay, and then you will have some substances that will catch fire on its own. Look here, What does it says here? Read the given paragraph.
The type of combustion in which heat and light are released in a very short span of time is called rapid combustion. For example, combustion of LPG. The type of combustion in which substances catch fire on their own without the application of heat is termed as spontaneous combustion. For
Spontaneous
example,
combustion.
spontaneous combustion. For example, forest fires.
Okay. So in first type of combustion, that is rapid fire. Okay, we are providing heat here.
Yes,
Okay.
sir.
For example, when you burn an LPG burner, okay, you provide it with heat, okay, and it gives a very in a very short span of time, it will give excess amount of heat plus light as well.
Yes, sir.
Okay, so here in a short span of time, when I burned the fuel, I got heat and light. While there are some another type of combustion like spontaneous combustion, where I'm not providing the substance with any form of heat, but still it catches fire, okay, on their own. So in a forest, when there is no rainfall for a very long span of time, the plants become dry. Okay, the plants become dry, and when the weather is too hot, when the plants when the winds will blow, the plants will rub against each other, right? The branches of
Yes,
the
sir.
plants, they have gotten very dry. There is no moisture left in them due to no rainfall and excess amount of heat there. So when the branches of the plants are rubbing against each other, there is production of heat. So that due to that, there is spontaneous catching of fire. Okay, so that is how spontaneous combustion takes place. All right, got
Okay.
this?
Yes, sir.
Okay, so this is how forest fire takes place. Okay, like no one intentionally goes there and causes a fire. Okay, so this is how forest catches fire. Now let's talk about fuel. Now, what is a fuel?
Uh,
Yes, Ahmed, how do we define a fuel?
sir, fuel is the the liquid that charges the machines and
No, it is not necessarily that it will be liquid. Like coals are used in electricity power plants to produce steam. It could be liquid, it could be solid. Okay. The thing is,
okay, sir.
how do we define fuel? Like we have solid fuel, liquid fuel, and gaseous fuel as well. Okay. So fuel is what? It is basically a material which is used to produce heat. So we say that a material used to produce heat is called a fuel. Okay, what are some examples? We have got wood, you have got charcoal,
Charcoal.
yes, and what else?
Coal, coke, sir, and kerosene
Kerosene, diesel,
and diesel. Yes,
and
lubricating oil.
no, that is not a fuel. Lubricating is not oil is not used as a fuel. That is basically used to reduce the friction.
Okay, petrol.
Okay, petrol that we have included. Yeah, petrol, biogas, etc. That's enough examples, right? So these are basically substances which are basically used to produce heat. So those substances you will categorize, you will call them as what? You will call them as fuel. Okay. So the fuel will also be of three. They will be also in three different states. So fuel can be solid. Yes, they can be liquid,
Yes,
and they can be existing in gaseous state as well. Okay. So what are some examples of solid fuels, Ahmed? They are wood, charcoal, coal, as you mentioned, coke.
Yes.
Okay. And agriculture waste like cow dung, cake are also used as a fuel. Okay. Now, some examples of liquid fuels. As we see, there are kerosene, petrol, diesel, and alcohol as well. Alcohol can also be used as a fuel.
Yes, sir.
Okay. Now, give some examples of gaseous fuels.
Yes, you can repeat.
Give some example of gaseous fuels. Mister, there are so many examples of gaseous fuels.
Yes, sir. Gasolines and is nitrogen count as a gas?
Hmm. Nitrogen? No, nitrogen is not used as a fuel.
Uh, Helium, carbon
Helium is
dioxide,
also not used. No, carbon dioxide. You have so many examples. Like if you remember from the previous chapter, natural gas,
natural gas.
natural gas, no? You have got petroleum gas.
Yes, sir.
Did you forget about the coal gas?
Coal, I think.
Did you forget about the coal gas, Ahmed? We talked about this now in previous chapter.
Oh,
Coal
yes.
and petroleum. What, by
Coal,
the way,
coal,
what were the products of coal? We obtained
coal.
three products of coal. Yep.
So there is coal gas and there is coke and there is coal tar.
Very good, very good. We obtained this via
Coke.
destructive distillation of coal,
Yes, sir.
right? Okay, so all these fuels, whether they are solid, liquid, or gas, they are being used in different industries for running for different purposes. For they are being used for running automobiles. Mainly we use mainly we use liquid and gaseous fuels for running automobiles. Okay, now let's talk about ideal fuel. Like, what is an ideal fuel? What do I first mean by ideal fuel? So any fuel which burns at a good rate, gives off a good amount of heat and light. Okay, it
Yes.
can be transported easily from one place to another. It is available in abundant amount in nature. That will be called as a ideal fuel. Okay, so what are the things which we look for in a fuel? Okay, so things which we look for in a fuel is that it must be having a high calorific value. High calorific value.
Okay. High
What
calorie.
else? It should be easily available.
Easily.
Easily available and easy to transport. Okay, next thing, that it burns easily.
Oh,
It
sir.
burns
Usually
easily.
all petrol fuels burn easily, right?
Yeah, fuels, no, not all fuels burn easily. Like if you have got coal and you try to burn coal, it will not burn very easily. You need to add some extra catalyst in it. Like you need to add some papers or draw a straw to burn it. Okay, and its ignition temperature should be it should have a proper ignition temperature. Like as I told you, different substances have got different temperature at which they will burn. Okay, like if I give
Oh,
you to burn a petrol and at the same time I give you a piece of wood to burn, in which case to burn which substance you will require more amount of heat?
wood.
Wood, obviously. So the fuel we are looking for, it should have a proper ignition temperature, like neither too high, neither too low, neither too low. So proper ignition temperature. Next thing we look for in a fuel is that it should not produce harmful gases. So no harmful gas should be released when you burn those those fuel. Okay, it should be cheap, right?
Yes, sir.
It should be cheap and it should be readily available and it should be easy to support. Okay, but if you see in nature, but if you see in nature, does ideal fuel even exist?
Yes, sir.
Like, is there any fuel which have got a high calorific value, which can be
Uh,
which is easily available and can be easily transported, which is
yes, sir.
cheap, okay, which
Petrol.
burns easily, which have got a good ignition temperature and does not produce any harmful gas? Is there any example of such fuel?
Yes, sir. Gasoline,
No,
petrol,
no, no,
oh,
those are not cheap.
what's the
Those are
other one?
not cheap. Look,
Diesel.
you need to consider all the factors here.
Oh, all the
Diesel gives
factors.
off harmful gases
Oh,
when you burn diesel.
kerosene, kerosene.
No, in fact, kerosene is also not a good fuel because it does not have a very good calorific value in comparison to LPG. Okay, and it also releases
Oh,
harmful gases. Yes,
oh, sir, CNG, CNGs.
which CNGs? Look, CNGs are not cheap now.
Then LPG.
LPGs are costly, right? So you
Bitumen.
see, the thing is, no. In fact, not even coal or coal products. The thing is now, there is no fuel which can be considered to be an ideal fuel. Okay, so in
Oh,
nature there is no fuel which meets all these five criterias. So there might be fuel which will be meeting two or three criteria out of this, which we choose for our use. Okay, so that is the thing. Okay, so let's talk about calorific value and efficiency of a fuel. Okay, so we know that all the fuels which we use, one thing common about all of them is that all of them produce heat on burning. Okay, but however, not all of them gives off same amount of heat. Different fuels will give off different amount of heat on burning. Okay, so some fuels produces more heat while some fuels produces less heat. So how do we explain the efficiency of the fuel? Okay, like the fuel which is giving a good amount of heat, that is very uh, that is having a that gives you a good amount of heat, that is more efficient, right? And then you have got
yes, sir.
fuel which produces less amount of heat, so they are less efficient. Wait a minute. So their efficiency is represented in the form of their calorific value. So what is this calorific value we're talking about? Read the given paragraph here.
The amount of heat energy produced on the complete combustion of 1 kilogram of a fuel is called a calorific value. The calorific value of a fuel is expressed in a unit called kilojoule per kilogram, kg,
Kilojoule per kilogram.
kj, kg.
Yeah, kilojoule per kilogram. Okay. So
Kilo,
by calorific value, we will simply mean that if you have got 1 kg of fuel and the amount of heat given by it is simply the calorific value of that substance. Okay, so the amount of if you remember, the unit in which we measure heat, it is actually joule. Okay, the unit in which you measure heat, that is what? That is joule. Remember this. Okay, and 1 kilojoule is equal to 1000 joule,
yes, sir.
right, Ahmed? So joule here is the unit of
Yes, sir.
heat here. Okay, all right. And what is how much is 1 kilojoule? How much
One
is
kilo,
1 kilojoule? That is, it's written over
uh,
here.
sir, it is 1 kilogram.
No, it is obviously written here. No, 1 kilojoule equals to 1000 joule. I have written here. Okay,
Oh,
so the calorific value of a fuel is expressed in a unit called kilojoule per kilogram. So if you are burning 1 kilogram of joule, you will get amount of heat released. Okay, so joule is a smaller unit and obviously kilojoule is a bigger unit. So if you have got only so 1 joule is comparatively smaller to 1000 joule. All right, Ahmed. So 1000 joule is, in short, it is called as kilojoule. So let's say if I give you 1 kg of kerosene and you burn it completely, the amount of heat released will be 45,000 kilojoules. Imagine here. Imagine this thing here. Look, if I have got a table here, I would have shown you. No, like different substances. Now, in your NCERT book, we will see that there's a table where the calorific value of different substances have been shown. Okay, so let's say I give you a few examples here. Like I give you cow dung, I give you petrol, and I give you hydrogen gas. You must have heard about hydrogen gas being used as a fuel in vehicles. Okay, nowadays there are cars which can run on hydrogen gas, spaceships in them also, the rockets which takes satellites into space, they also use hydrogen as a fuel. So suppose I give you three different types of fuel. One is cow dung, one is petrol, and one is hydrogen gas. Out of these, which fuel will give you maximum amount of heat?
A kilojoule.
No, which will give you maximum amount of heat? I'm not asking about the unit of joule. I'm simply asking you which will give me maximum amount of heat here.
The maximum.
Look, in comparison to cow dung and LPG, which one is better?
In count LPG.
LPG, because it will give more amount of heat. Okay, so if you burn 1 kg of cow dung or if you burn 1 kg of petrol, obviously 1 kg of petrol is going to give you higher amount of heat, more amount of heat. And we basically express that amount of heat in calorific value. Got this, Ahmed? So the calorific value of petrol is higher in comparison to cow dung cakes. Okay. Now in comparison to petrol and hydrogen gas, which will give you more amount of heat?
So can you repeat the please?
Yeah, in comparison to petrol and hydrogen gas, which one is going to be giving you more amount of heat?
Hydrogen gas.
Hydrogen gas, obviously, right? Like if you burn 1 kilogram of hydrogen gas, it will give you 150,000 kilojoule of heat, right? And if you just burn 1 kilogram of petrol, it will just give you 45,000 kilojoule. Right, Ahmed?
Yes, sir.
Okay, so that is about calorific value. Okay. Now, again, the same question, like, can you burn a piece of wood or coal using a matchstick?
Can you, sir?
See, it's written over here. Read the first line.
Can you burn a piece of wood or coal using a matchstick? No, sir.
No.
Oh.
Why? Because
the matchsticks doesn't have that much heat, sir, and also the fire capacity.
exactly. It does not produce enough heat for the coal or piece of wood to catch fire because of different ignition temperature. Okay, remember earlier we talked about ignition temperature. That is simply the minimum temperature required for a substance to catch fire. Okay, now let's understand about working of a matchstick here. Okay, so you must have used a matchstick here. So the side of the matchstick, where you rub the matchsticks, that is made up of what? It is made up of, see, if I zoom the figure, now you can see it properly now. See, it is made up of powdered glass and red phosphorus. Okay, so the stripe on the side of the matchbox you see here. Okay, are you able to see the? Can you see the figure here? So they are now basically made up of powdered glass and red phosphorus. All right, Ahmed. So when you rub the matchstick across this, it leads to friction, and due to friction, heat is produced, and hence the head of the matchstick catches fire. Okay, so read this one here. Working of a matchstick. Read this paragraph.
Uh, okay, sir. Working of matchsticks. The main component of the bulb of a matchstick is red phosphorus, which turns into the white phosphorus on heating. White phosphorus consciously ignites, thereby increasing the temperature of wooden stem to the ignition point, and the matchstick start burning. Uh,
Exactly. So you see, the stick of the matchstick is made up of wood here. Okay, so if you were to simply rub the wood to this strip of the matchbox, will it catch fire? No,
uh,
obvious. If you try to
yes.
light the back, like the opposite side of the matchstick, the wooden side, and if you rub it across this strip of matchbox, it does not catch this fire. Okay, because the thing is here, although the friction will be produced, but the wood will not gain enough heat to catch fire. So that's why you have got the bulb of
Okay, sir.
matchstick that is made up of red phosphorus. Okay, so the property of red phosphorus is that it is a inflammable substance, like it will catch fire when when friction is produced. All the time. Actually, I'm not able to use my pen because it got discharged. Okay, so I'm not able to write anything here. Okay,
Okay, sir.
so this is how a matchstick works here. Got this. Now, will you be
Okay,
able to
sir.
explain the functioning of matchstick if someone asks you? How will you explain it to the person?
Uh,
Like, say
the
I'm a lame person, I don't know how a
functions of
matchstick works. How explain it to me how a matchstick works?
oh, how does a match work?
Yeah,
Uh, so the main component of a bulb of a matchstick is red phosphorus, which turns into white phosphorus on heating. White phosphorus spontaneously ignites, thereby increasing the temperature of the wooden stem to the ignition point, and the matchstick starts burning.
exactly. This is how matchsticks catch fires. So when the bulb of matchstick it got ignited, it catched fire. Then the wood reached its ignition temperature. It got the minimum temperature required to burn. So the wood of the matchstick also caught fire. Okay, I hope it's clear. Okay,
Yes, it is.
okay. Now there's a small history of matchstick. Okay, like you see the history of matchsticks. It is quite old. Like it is as old as 5,000
Oh,
years. Okay. So what happened now? Just read this paragraph
five.
and we will get to know the story behind Matchstick. Read this one.
The history of the matchstick is very old. More than 5,000 years ago, small pieces of pine wood dipped in a sulfur were used as a matches in ancient Egypt. The modern safety match was developed only about 200 years ago. A mixture of antimony trisulfide, potassium chloride, and white phosphorus with some glue and starch was applied on the head of a match made of suitable wood. When struck against a rough surface, white phosphorus got ignited due to the heat of friction. This started the combustion of match. However, white phosphorus proved to be dangerous both for workers involved in manufacturing matches and for the user. These days, the head of safety match contains only antimony trisulfide, and potassium chloride. The rubbing surface has powdered glass and a little red phosphorus, which is much less dangerous. When the match is struck against a rubbing surface, some red phosphorus gets converted into white phosphorus. This immediately reacts with potassium chloride in the matchstick head to produce enough
feed to ignite antimony trisulfide and start the combustion. Okay. So earlier they used to glass pieces in it. Okay. You see, now the manufacturing was changed, and nowadays for safety concerns, only antimony trisulfide and potassium chlorate. Remember the two names here. These two names are important here. Okay. So antimony trisulfide and potassium chloride are used in matchsticks. Okay. Just remember the two names here. This one is important thing from this given paragraph. Okay. Okay. All right, then, Ahmed, that's it for today. And you need to revise whatever we have discussed so far. Okay. Because I noticed this thing that you have a hard time in recalling few things. Okay.
Yes, sir.
All right, then. We will meet in next class then. Any confusion regarding today's class?
Sir, is the matchsticks?
Yeah.
How that when we did the matchstick,
Yes.
that I didn't got that very well, sir. I didn't got that very well.
Okay. Okay. Look, how it catches fire. That is what you're asking, no?
Yes, yes.
Okay. Look. Yes. See here. See this. This brown strip here. Yeah. See if it works here. This brown strip which you are seeing here, it is made up of red phosphorus and powdered glass. Okay. The tiny pieces of glass made into powdered together with red phosphorus, both of them are glued together. All right. And
Okay.
they are attached, they are stick to this strip on side of the matchbox. Okay. Now, red phosphorus is a combustible substance. It is a combustible substance, meaning that it can catch fire. If it gets even a small amount of heat, it will catch fire. Now you have got a piece of matchsticks. This is its head. Okay. It is also containing what? Red phosphorus.
Red phosphorus.
Right, Ahmed? Now,
Okay, sir.
the wood, if you were to simply rub this wood against this strip, it will not catch fire. But if you rub the head of the matchstick against this strip that is made up of a powder glass and red phosphorus, what happens when you rub it against it? Friction is produced, and friction leads to production of heat. Right, Amit? So this red phosphorus has got some amount of heat when we rubbed it across the strip of the matchbox. Now, due to heat, it will start to catch fire. Okay, now once the head catches fire, the wood piece of the matchstick will have got the ignition temperature required to catch fire. Okay, like earlier when I was rubbing the wooden portion of the matchsticks against the strip, it will not catch fire because it was not getting the required temperature to catch fire. But when I rub the head of the matchsticks against this strip that is made up of powder glass and red phosphorus, heat was produced due to friction, and that small amount of heat was sufficient for red phosphorus to